Hi, my name is Ronald Heath, and this video is about an experiment that will probe into the nature of time itself. I'll begin with an overview of the experiment, then discuss the theory and possible meaning of the results. After that, I'll show you the results and how they were analyzed. Finally, I'll describe the experiment with enough detail for you to duplicate the experiment in case you're interested. Throughout this video, I'll use a computer-generated voice. This will make it easier for me to do the editing and also easier for you to understand the words.
Here is the experiment hardware setup. This is the computer that is running the Ubuntu Linux operating system. I started out with the Raspberry Pi 5, but now I use the Geekom Mini Air 12. This is the aluminum project box for the experiment. The tree rings on this piece of wood have recorded 30 years of growth conditions. The centimeter scale is just for reference. This 4K USB camera has mechanically adjustable settings. An ordinary USB camera would not work here because it would continually readjust itself and cause false change detections. This light box was chosen because it can run while charging and it has an adjustable brightness. The computer will take an image and save it as image 1. It will take a new picture and save it as image 2. If the pictures are the same, it will throw away image 2. It will continue taking a new image 2 every 10 seconds. Each time it will compare the image 1 with the image 2. If image 2 is different from image 1, the computer will save both pictures with a timestamp and update a log file. The present picture, image 2, will be saved as image 1. The computer will then continue taking and comparing a new image 2 every 10 seconds. The block theory of time says that time is like a book. We progress from one second to the next like turning to the next page. In the static block theory, the whole book of time is fixed and free will is an illusion. The dynamic block universe or DBU is also like a book, but the characters in the book can change their minds using free will. The changes will propagate from the past into the present. For example, refer to the classic Mandela effect where the guy who drew the Monopoly character with a monocle decided to draw him without a monocle instead. This change propagated into our present time, but the propagation was not perfect, so some people remember the monocle even though there is no monocle now. If the DBU is true, there are changes that are continuously happening in the past and we usually just remember that things have always been that way. Our memories become updated as the changes propagate through our present time. What if a computer were to store a picture from the past and compare it with a picture in the present? Would the pictures be different when a change is propagating through? If the rate of propagation is any slower than instantaneous, there should differences between a picture that is taken just now and a picture that has been taken in the past. If the DBU is true, maybe the weather has changes that propagate through time as well. An easy way to get a record of the weather during a block of time is to slice a section of a tree and look at the tree rings. Each ring represents 1 year of tree growth. If there is a change in the weather, or a person decides to make a campfire nearby, the ring for that year will be different. There is also the possibility that present events propagate from the present to the past. The evidence for this is the double-slit experiment where an observer affects the photons before they reach the observer. I will now show you the results of my experiment. You can download all of the most compelling results from my webpage. The zip file will be updated whenever I capture an interesting change. This picture is from the capture results zip file. It shows the location of the change in a red box near the lower middle of the screen. Zoomed areas of the two captured images are shown side by side with another red box around the change. The shapes above and below are the same, and this eliminates the changes due to lighting and focus. While this is a small change, it does look to me like this area has changed shape. Here is another picture from the zip file. Note the shape of the area near the cursor. One is clearly larger than the other. Here are 4 more compare files. All of the program files are available on my web page. The files need to be extracted to a directory on your hard drive. The 2 programs need to be compiled by entering each directory within a terminal and typing make. Please read the file tree ring notes.txt. Helpful tips and required installations are listed here. This is the script that will run the programs. We will define how to take an image from the camera here. Some initialization to avoid errors when the script is first run are placed here. Remove the old image 2 and capture a new one. The convert program that is part of the ImageMagick installation will create a view of image 2 that is easy to view on the screen. The chop merge program will show a black line between the 2 images that will be compared. This will show the place where the differences between the files will be measured. This will create another view of the file from chop merge program. Here is where the 2 image files are compared. The text from the tree ring monitor program will be displayed on the screen. If a detection has occurred, put a message on the screen and then copy image 2 to image 1. Also, a conveniently sized view will be created. The computer will wait 10 seconds and then continue around the loop again. The Geekom Mini Air 12 is controlled remotely using real VNC. I will create a new directory for this run. The script file will need to be copied into the new directory so that when I decide to change the script, the old runs will still have the script that they use. I will now run the script. As the script runs, you can see the image 2 being created and deleted every 10 seconds. If you double-click on the chopview.jpg file, you will see a black line that shows where the tree ring monitor program will do the comparison. The tree ring monitor program will start at x equals 1, the far left of the screen, and y equals 750. The pixel above y equals 749, the present pixel, and the pixel below, y equals 751, will have the red of image 1 averaged together, then subtracted from the red average from image 2 and the absolute value of the difference added to the total. Same thing for the green and blue, then the next pixel. If this is a bit confusing, the actual code is in the zip file. Anyway, the file view chop.jpg is also available for a better view. I usually open view2.jpg and let it run. I check every few hours to see if there are any detections. If there are detections, I open the log file. I simulated a detection by changing the detection threshold in the script and then restarting. I will copy the log file and the 2 output pictures to a new directory in the Samba share directory so that I can open them on my main computer. I will double-click on out file 1. When the picture comes up, I can move back and forth between file 1 and file 2 with the arrow key. This makes it easier to see any differences.
Thank you for watching. Please be sure to like and subscribe.